Okay guys, so the next one we're going to be having a look at is going to be queues. Oops. So queues are very similar to stacks, except they work on a first in, first out principle. So that is, the thing that arrives first is dealt with first. The thing that arrives end goes to the end of the queue to wait for something to happen. So we have enqueue, and we have dequeue as our two main functions or methods. Enqueue is going to add an item. So if I were to enqueue A, it's going to appear there. If I was to enqueue B, it's going to appear there. If I were to dequeue, and this is where it's different from a stack, it would take the item at A and remove that. If I were to dequeue again, it would take the item at B and print or remove that. Okay, so what pointers do we need then? Well, we need a head pointer, and that's going to be the start of the queue. Could be head, could be start, could call it what you like. But my start of the queue, at the very beginning, is going to be -1, because there is nothing. Now, my rear or tail pointer, it's called tail, is going to start at 0. And that's the space where I will add the next item to the queue. Do I need anything else? I could possibly have a max size to deal with the maximum size of the queue. It depends on what type of queue I'm doing. Do I want it to be circular? Do I want it to not be circular? So let's just do the most basic queue, at least to begin with, and then we can think about more advanced stuff later. So when I add an item, what I'm going to do is I'm going to say that I'm going to add to the tail. Now, in this case, if it were this size, I could say that if the tail is greater than the index, greater than the max pointer, then I know that it's gone too far. That I know the queue is full. Now, again, there's different ways to do this. It's one of the more versatile ones where you can have a circular queue. So let's do it the most simple way first to begin with, and let's just make it like this. So head is -1. Now, if I add an item to the queue, I'm going to check, is the head -1? If it is, then I'm going to set the head to be equal to the item I placed. I'm going to place the item at location tail. So let's say I put on A. So A goes in location tail, and I add 1 to tail. If the head is -1, then I'm going to set the head to be 0. Easy. Now I'm going to enqueue another item. So let's say I enqueue B, which is at position tail, and therefore I'm then going to add 1. Notice my head does not change. The next one, C. So C is going to be, C is going to be enqueued at the tail position. And then my tail is going to increase by 1. Now at some point, tail is going to be equal to the 5. So while it's less than or equal to the max pointer, actually, then I can continue to enqueue the items. So let's say we had C, D means tail is going to be 4, E means tail is going to be 5. So at this point, the tail is 5. So I'm going to say that, so I still want to be able to add it. So if the tail is less than or equal to the max pointer, then I can add it. However, next time the tail is going to go up to 6, and that means the tail is greater than the max pointer, and so I'm going to give an error. Now what about dequeue? Well, dequeue is going to go to the head, and it's going to remove that item, or just move the pointer, and it's going to move the pointer up by 1 each time. So then I've dequeued A, so B is now the head. I'm going to dequeue B, so C is now the head. Now you notice that basically there's a sort of finality to this queue. At some point, I'm going to have added enough items, but it doesn't matter what I dequeue, it's still going to be stuck. So For a more advanced queue, we can use a cycle, which means that so for example here, if the tail pointer, I'm going to say if it's greater than 5, then set it back to 0. Yeah, and rather than max pointer, I'm going to say that if the tail pointer equals the head pointer, then I know I've gone too far. Sounds complicated. Let's check it and see. So this is going to be my head pointer, and my tail pointer is here. Okay, so let's clean that up for now. Okay, so my tail is here. So let's add an item. So is the tail pointer equal to the head pointer? No, it's not. So I can add an item at position 5. So I'm going to add F. And I'm going to add one to the tail pointer. Now, what I said in my code is that if the tail pointer becomes greater than 5, then I want to change the tail pointer to be 0. Okay, now I'm going to add E, F, G. So I'm going to add G at the tail. Now, first of all, I check, is the tail equal to the head? No, it's not. So I can add in G. And my tail goes up by 1. Now, once again, A, B, C, E, F, G, H. I'm going to add H at position 1. And I'm going to add to the tail. Now, next time, I'm going to try and I'm going to try and add I, but my rule is if the head pointer equals the tail pointer, then I'm going to say, nope, it's full. However, if I were to dequeue the first element, which was C is now gone, and my head is increased to 3, well, my tail pointer is no longer equal to my head pointer, so I could still go on to enqueue in this space here. Okay, and that's a quick theory on how we deal with queues and cyclic queues specifically. Cyclic queues, I've not seen that commonly in the exams, so they often just have a finite number. It doesn't make much sense, but I guess they don't want it to become too complicated in an exam situation. So say thank you, Mr. Examiner. Okay, we'll go on to do the practical in a moment.